Hello everyone. In the previous section, we have discussed about what is chain in conditionals. So the now let us discuss about what is nested conditionals. So nested means obviously we know one condition can be nested within another. How we can do that? For example, consider this example. We have f is equals to x. If x is equals to y, then we are printing x and y are equal. Else, if x is less than y, we can print x is less than y, else we can print x is greater than. This is how we can use the nested conditional. Okay, so what is the initial condition is if x is equals to y, if it is yes, it will print equal, otherwise it will check for another condition, that is x less than y. If it is true, print x is less than y, otherwise it will print x is greater than y. Okay, so this is how we can use the nested conditionals in the Python programming language. Okay, so the next topic is catching exceptions using the try and except. Okay, in generally exceptions meaning is errors. Okay, exceptions means you are making the user to know this is what the error you are giving, please give it in the proper way. For example, the user is trying to give some input. For example, say the my input should be an integer number, but user is trying to give the string. That is an exception, right? So the it should using the try and the except statements, we can try and except syntaxes or the statements, we can get out of this exceptions or the errors. Okay, for example, say when you want to know the Fahrenheit or the temperature, what would you use? You should ask for the user for the enter the Fahrenheit temperature. For example, say I have input is equals to user asking the user to enter the Fahrenheit temperature. So in INP is equal to input of enter Fahrenheit temperature. So you try with the set of the block statements. So Fahrenheit is equals to float of the input. Okay, it should convert, it is converting the Fahrenheit in the to floating point numbers. So if input is integer, it can be converted to floating point number. So it should convert Fahrenheit temperature to Celsius. So formula is Celsius is equals to Fahrenheit minus 32 into 5.0 divided by 9.0. So when you print the Celsius, you should have an exception. When you try with this one, you should have an expression, please enter a number. Why? For example, if user is giving some other string, what is the it should throw you out an exception, that is please enter a number. You have entered something wrong, please enter a number. Okay, for example, when you try to execute this one, user is entering temperature, that is 72. So 72 can be converted to Celsius, that is it is converted to 22.222. So this temperature in the Fahrenheit is converted to 22. In the similar way, when the user is trying to give some other string, for example Fred, this is a string. Okay, so in such case it is throwing out an exception, please enter a number. Okay, so this is how we can use the how we can catch the exceptions using the try and the except statements. Okay, so the next one is short circuit evaluation of the logical expressions. Okay, when this Python is processing a logical expression such as x greater than or equal to 2 and x divided by y greater than 2, it evaluates the expressions from right left to right. Okay, so I have two expressions here, x greater than or equal to 2 and x divided by y greater than 2. So evaluation is done from left to right according to the rules of the precedence. Okay, since the because of this definition and since the definition of and, if x is less than 2, the expression x greater than equal to 2 is false. If it's x less than 2, the expression will be false, and so the all expressions will be false because we are using the and logical operator here. Okay, we know the logical operator or the condition for and is either of these expressions, these both the expressions must be true, then only we can see the complete expression is the true. Okay, fine, regardless of whether x divided by if this x divided by y greater than true, if this evaluates to be true, then if condition is false, then we can say the complete expression can be considered as the false. Okay, so when the Python detects that there is nothing to be gained by evaluating the rest of the logical expression, it stops there and it does not execute the next expression, and it directly gives you this expression is false. So when the evaluation of the logical expression stops because the overall value is already known, then it is called as the short circuit evaluation. So my meaning is short circuit evaluation means, for example, I have this condition seems to be false. Okay, so this condition is false but this is true, but it does not going to count this condition is true or not false. Once this is false, it does not going to check for the other one, it immediately stops there and gives the output. That is the meaning of the short circuit evaluation. Okay, so this seemed to like a fine point. This short circuit behavior leads to the clever technique called, that is called Gaussian pattern. Okay, so that is the meaning of the short circuit evaluation. Okay, you can also see some examples like this: x is equals to 6 and y is equals to 2. So x value of x is 6 greater than or equal to 2, so this is true. So if this is true, it will check for the next condition, x divided by y. 6 divided by 2 is 4, that is true, that is greater than true, that is true. So the obviously the output should be true. X is 1 and y is equals to 0, x greater than or equal to 2, so 1 is not greater than 2, so it stops here, it does not going to evaluate this condition, so this is going to give you false. Then next one, x is equals to 6 and y is equals to 0. In such case, the first condition is true, you want to check for the second condition. Now you have 6 divided by 0, so what will be the output? You cannot expect this is the true, because it will give you divide by 0 error, because 6 cannot be divided by the 0. Okay, so this is called the how we can use the short circuit evaluation of the logical expression. We have another example here: x is equal, x greater than or equal to 2 and y not equal to 0, and x divided by y greater than 2. We have three conditions here. Now the first one is x is 1, so 1 is not greater than, it is not going to evaluate these two expression and it returns the false value. X is equals to 6, y is equals to 0, and x so in such case, what should be the x is greater than or equal to 2, this is true. Next, check for this condition, y not equal to 0. This is false because y is 0 here, so this stops here and it does not evaluate here. Okay, we have another one here: x is greater than or equal to 2. What it is showing? Division by 0 error. Okay, again it is counting that divides by 0 error, y not equal to 0. Okay, so that is how we evaluate the logical expressions. Okay, so this is all about the conditional executions in the Python programming language. Thank you.